And now for our last two types of graphs that we'll cover in this section. First is the dot plot. A dot plot is pretty much what it says. They can be used to display various types of information, whether it's numerical or categorical. And in a dot plot, each dot represents a data value. And the heights of the dots can indicate the frequency of the data. We have an example here. A researcher with AC Nielsen. Nielsen is a big company interested in television ratings. The researcher wanted to determine the number of televisions in households. He conducts a survey of 40 randomly selected households and obtains the data. We want to create a dot plot. So we start out a dot plot with a line. A dot plot's similar to a bar graph in that the heights of the dots indicate the frequencies, but this time we're going to say that each dot represents a data value. So we look at our data here. Usually dot plots are used for small amounts of data, so it might be for an ungrouped frequency distribution, for example, or a categorical frequency distribution. So we have 0 TVs, 1 TV, 2, 3, 4. We could have a category for 5, and these are indicating television sets in the household. And then we go through each one of these data values and we plot a dot, one on top of the other. We want the spacing to be about the same between the dots, so that 5 2s would look like the same height as 5 1s. I'm going to finish this out. You pause the video and finish it out, and let's compare our graphs when you resume. Okay, hopefully you finished your dot plot. Hopefully it looks a little bit like mine. 1 at 0. 14 in both 1 and 2, 8 in the 3 category, 2 4s, and 1 5. If we were classifying this distribution, what would we say? Well, since I start low, I go high really fast, and then I go back low. We could call this a right-skewed distribution, even though we normally talk about the nature or the shape of the data with the histograms. We can do that here. A dot plot is just a different representation of the same data. We could create a histogram from a frequency distribution of this data. We could also possibly call this bimodal because we have two categories that both reach a maximum and it's the same. So even though the bimodal in the example before, when we talked about the nature and the shape of the graphs, looked like it dipped down in the middle, it doesn't have to. We can have two values that are exactly the same next to each other, and since they're equal and they're both the maximum, this could also be considered bimodal. Either of those is fairly acceptable. And then our last graph is a stem and leaf plot. A stem and leaf plot is a different kind of data plot, but this time we're actually going to use the data to create the plot, but not like before. Before we've been using lines, bars, dots, pie graphs. This time we're actually using the numbers themselves as the graph. So here we go, a stem and leaf plot, a data plot, using part of the data value as the stem and the rest of the data value as a leaf to form groups. So we've got an example for grams of fat in McDonald's breakfast, in different types of food offered. Let's create a stem and leaf plot and I'll show you how we do it. All of this data, with the exception of two values, has 2 digits. Digits are just how many numerals we have in the number. Before I get into that part though, I do want to point out one quick thing. If I have a big number, like 7,843.21, all of these places have names to them. So the 3 is in the ones spot. The 4 is in the tens spot. The 8 is in the hundreds. The 7 is in the thousands. 7,843. After the decimal, we have tenths and hundredths. And if we kept going, we'd have thousandths and 10,000ths and 100,000ths, in the same way that we have 10,000s and 100,000s to the left of the 7. So all of these different place values have names. What usually happens with a stem and leaf plot is the number is broken into two parts, into a stem part and a leaf part. I know that's a little messy, but the stem and the leaf don't have to be broken up at the decimal. It could be broken up by everything but the last digit and then the last digit. It depends on our data set and what that data looks like, how we would split our stem and leaves apart. So we'll move our little reminder over here out of the way, and let's talk about stem and leaves. So stem on left side, leaf on the right side. Since we have two digits, we're going to let the stem be the tens digit and the leaf be the ones digit. I have two numbers, as already mentioned, that don't have a 10 spot. So that means we have 0 for a placeholder. It's okay to put 0 there. All the other values that we see, 1, 2, 3, 4, or 5, we can put those in there. And then we write down the ones part in numerical order from smallest to largest. And we also want to line them up next to each other in a pretty regular way. So let's start with the stem. 0. We have 3 and 9. For the stem of 1, this means we have a 1 in the 10 spot. I have 11, 2 16s, and a 12. So I'll have 11, 11, 12, 16. For the 2s, 27, 22, 25, 21, 22, oh I forgot 24, 24, 25, 27, 27. For 3s, we have 30, 31, 32, 37. And notice that I am repeating the values that I see. So I see 2 30s, a 31, 2 32s, a 36, and a 37. For 40s, I have a 46. And then for 50s, 51, 55, 59. And this is a stem and leaf plot. A stem and leaf plot is pretty cool for a couple of reasons. The first one, if you look at the data from the side, we can see the shape of the data right here in this stem and leaf plot. We would just have to rotate our paper to the side so that our stems are along the bottom, and we can see the heights of the leaves that help us indicate the shape of the data. I would probably say that this data is more, we could say it's bimodal because these two have the same number of values in them. We might also get away with possibly a right skew, and I say right skew because I have 6 data values before and I have only 4 after, so there are more data values to the left. So a couple of different ways we can classify it. The second reason that a stem and leaf plot is pretty amazing is if we're not given the data but we're shown the stem and leaf plot, we can actually recover every single data value here. I just read off the stem and leaf. Stem is 0, leaf is 3, that's a 3. Stem is 0, leaf is 9, that's a 9. 11, 11, 12, 16. I'm grabbing the stem and then the leaf that goes with it. 21, 22, 22, 24, 25, and so forth. So I can recover all of my data. None of the other tables can really do that for numerical data, unless they're an ungrouped frequency distribution. The grouped frequency distributions all your data is hidden behind groups. Both the stem and leaf and the dot plot are not ones that I know how to do using technology, I'll be honest. So doing them by hand, perfectly fine. If you want to figure out how to do them using technology, I'd be really curious to learn how. So feel free to email me and let me know if you do figure out how to create them using Google or Excel. That concludes 2.3. There are a lot of graphs in this chapter. We've got our frequency distributions in the first section to organize our data, and then we create those graphs from that organization. In the next chapter, we'll be looking at ways to summarize our data.